Hello students, so here I am continuing my online lectures. In last semester I completed the course Applied Mathematics 4. Now I will try to complete the course Applied Mathematics 3. I am taking this according to Mumbai University syllabus. So we will start with the chapter Laplace Transform. In third semester, all branches have this chapter Laplace and inverse Laplace transform. So I will start this semester with Laplace transform. So first see the definition. So we are finding Laplace transform of a function f of t. So Laplace transform of the function f of t and notation for this. So for Laplace we are using capital L. So capital L in curly bracket given function. So L of f of t is defined as Laplace of f of t equal to integration 0 to infinity e raised to minus st f of t dt. So if this integration exists, then we can say it is a Laplace transform of this function. Sometimes we are using the notation in place of L of f of t as f of s, where this s is a parameter. Because when you are solving this integration, get your answer in terms of s. So we denote this function by f of s. In mathematics, there are several notations for Laplace transform. So these are some notations used in mathematics for Laplace. That is, the function is f of t, its Laplace is f of s. If it is small f of t, it is capital F of s, and so on. But in this course, we are going to use the notation, this notation. This is fixed for us. So next point is why to study Laplace transform. So Laplace transform is very important part in mathematics. We are going to solve ordinary linear differential equations with initial conditions. So this is important application of Laplace transform. And the origin of this or these ordinary differential equations appears practically under the study of electric circuits. So at the end of this chapter, we are going to solve differential equations using Laplace transform. This is the application of Laplace transform. Now next part is linearity property of Laplace transform. What is linearity property of Laplace transform? So Laplace of C1 f1 of t plus C2 f2 of t equal to, where C1 and C2 are constants. So take the constant outside the symbol L. C1 L of f1 plus C2 L of f2. We are going to use this linearity property in several examples. So remember this property. Now we will see some examples on Laplace transform. So first example, find the Laplace transform of the function f of t equal to t when t lies between 0 to 4 and it is 5 when t greater than 4. Dear students, here remember one thing. So when I am writing 5 and s, you will get confused. So remember that I will pronounce that word where it is 5 and where it is yes. Remember this is 5. So we will find out Laplace of this given function. So by definition, Laplace of f of t is 0 to infinity e raised to minus st f of t dt. Now see the definition. We are taking integration from 0 to infinity. But in this function, this interval is divided into two parts, 0 to 4 and greater than 4. So we will split this integration into two parts as 0 to 4 and 4 to infinity. So 0 to 4 e raised to minus st f of t is t. So on 0 to 4 value of function is t and 4 to infinity value of function is 5. Now how to solve these integrations? So for solving this integration, we will apply by parts rule, LIT rule. So here u is t, v is e raised to minus st. So u is t into integration of e raised to minus st. See here integration is with respect to t. So s is constant. So e raised to minus st by minus s minus derivative of t is 1 into e raised to minus st by s square. So we are using here Bypass rule, generalized bypass rule, plus this pi is constant. So pi into integration of e raised to minus st, e raised to minus st by minus s, limits are from 4 to infinity. Now substitute upper limit and lower limit. So in place of t we have to put the limits. So 4 into e raised to minus 4s by minus s minus here e raised to minus 4s by s square. This is upper limit. Minus lower limit. So this becomes 0 when we are putting lower limit, and this is minus 1 by s square. So minus 0 minus 1 by s square plus is 5 into upper limit e raised to minus infinity. But remember one thing, e raised to minus infinity is always 0. Write down somewhere. So upper limit is 0 minus lower limit is e raised to minus 4s by minus s. Now after calculations, so this is minus 4 by s e raised to minus 4s. This is minus e raised to minus 4s by s square. This is plus 1 by s square. And this is minus plus 5 e raised to minus 4s by s. Now see these two terms. 5 e raised to minus 4s by s. And minus 4 e raised to minus 4s by s. So this is 5 minus 4, which is 1. So this becomes e raised to minus 4s by s minus these two terms as it is. Now from first two terms we'll take e raised to minus 4s constant. So e raised to minus 4s. So remaining terms 1 by s minus 1 by s square plus 1 by s square. So this is the Laplace transform of the given function. Now second example, the given function is f of t equal to cos t when t lies between 0 to pi and sin t when t greater than pi. So here limits of integration are divided into two parts, that is 0 to pi and pi to infinity. So by definition of Laplace transform, this is the definition. Laplace of f of t 0 to infinity e raised to minus st f of t dt. Now on 0 to infinity is divided into two parts. So 0 to pi and pi to infinity. So on 0 to pi function is cos t and pi to infinity function is sin t. Now I have to solve these two integrations. So for solving such integrations we have standard formulas, e raised to ax sin bx and e raised to ax cos bx. So one similarity, so in both these formulas e raised to ax by a square plus b square is common term. Confusion part is where to use minus and where to use plus. This is confusion. So remember one thing, we know the properties of sine and cos functions. So sine function is odd function, that is sine of minus theta is minus sine theta, and cos is even function. So cos of minus theta is cos theta. So for sine, as sine of minus theta is minus, so remember in this way, here we are using minus sign. So e raised to x sin bx dx is, this part is common, a sin bx minus b cos bx, and e raised to x cos bx dx is a cos bx plus b sin bx. Remember in this form. Now for first integration we will use second formula. So we will replace a by minus es and b by 1. So after using these formulas, we will get these two things. So this is the formula for first integration, this is for second integration. Now we will put upper limit, lower limit. So here upper limit is pi. So value of this term is 0, sin pi. And for second integration, when t is infinity, This is e raised to minus infinity. So in second integration, upper limit is 0. So see here, after putting the limit, so in this step, I just substituted the limit. E raised to minus upper limit. So this is value of upper limit, the value of lower limit, plus this is value of upper limit minus lower limit. Now here this is 0. Cos pi is minus 1. So minus minus plus. What is remaining? S by s square plus 1 e raised to minus pi. Now here sin 0 0. What is remaining? Cos 0 is 1. So minus minus plus, and this term is 1. So s by s square plus 1. The second term. Now here this term is 0 because of this one. And here sin pi 0. What is remaining? Cos minus cos pi. But minus cos pi is plus 1. Cos pi minus minus plus. So remaining term is minus e raised to minus pi s by s square plus 1. See the calculations. Calculations are important here. So here from this sign this, we will take e raised to minus pi is common. So remaining here yes, here yes, here minus 1. So s minus e raised to minus pi is into s minus 1 by s square plus 1 plus s by s square. This is the answer. Now in the next lecture, we will see what are the functions, or of which functions we can find the Laplace transform, and some standard formulas or Laplace transform of some standard functions. Thank you.